In this lab, we will measure the gravitational acceleration g by letting an object fall freely under the force of gravity. The things we need are very simple. We first need some Lego blocks, then we need the IO lab, and finally we will need a flashlight. The idea is to shine the flashlight to the light sensor located on the IO lab, which is essentially here, and we will let the Lego blocks fall between the light and the IO lab. And because we know the separation of these little windows on the Lego blocks, and because the IO lab software can let us know when the light is being blocked, we should be able to calculate the acceleration of the free fall of the Lego blocks. So let me demonstrate that to you. So as you can see, this is the setup. We have the flashlight shining onto the light sensor of the IO lab, and we will let this little Lego block fall right through. And as it falls through, we should see dips in the intensity of the light, or as we call it, the eclipses. So let's first turn on the IO lab and start recording with the light sensor, and we will see a maximum intensity. So I'm just gonna go let this fall through, and let's start in 1, 2, 3. So this is how the data looks like, and this is when we dropped the Lego block. So let's zoom in on that. And again. And we can see every time there's a dip is because the Lego blocks the light. And whenever it comes back is because we're at the little window. So if we just figure out where exactly the light is being blocked, and because we can also measure the separation of these windows, we should be able to calculate the acceleration now. This is exactly what you'll be asked to explore during your next lab session. Your goal will be to produce good measurements of g by reproducing the simple experiment we just did. So good luck.